Welcome to Get XAML. Today we'll start a new concept, the Taylor series and the Maclaurin series. So what is Taylor series? This is a very simple concept. You have given some different types of functions. You are given different types of functions, say trigonometric function like sin x, exponential function like e power x. Okay. So when you do mathematical analysis to problems, then you may require sometimes to approximate that exact solutions may not be available. So it's better to convert them into some polynomial form. Okay, polynomial of sum of polynomials up to infinity. So assuming that at infinity will produce the exact function value. So let us see the definition of Taylor series. If function f of x has derivatives of all orders at x equal to a. Okay. The Taylor series about x equal to a is given like this. So what it means? The function has to be differentiable at x equal to a at all orders. At all orders means f dash of x is first order. Okay, we can write f1 of x first order, second order, third order, like that. Nth order differential should exist at x equal to a. This is the assumption. Then it is given as f of a plus f dash of a into x minus a plus the second derivative divided by 2 factorial into x minus a whole square plus so on. So this is actually the polynomial conversion of your given function f of x. Any given function can be converted into polynomial function like this till you go on adding each polynomials. First differential, second differential, third differential till infinity, you will get back your original f of x. So you are converting your any type of function into a polynomial function. In this equation, if I put a equal to 0, that means here a equal to 0, then I will get the Maclaurin series. So Taylor series and Maclaurin series are same, but only thing is Maclaurin series is the special case of Taylor series where a is equal to 0. Now you'll understand why it works. Why the concept of derivative understood. For example, when I say the first term here, the first term in the this is f of a, the function value at a. So this gives some information plus f dash f a give me slope at that point a. F double dash gives me about the concavity or convexity of the curve. So based on this, so a polynomial built for this derivative matches the function more closely as more terms are added. So Tn of x, let us represent it as the Taylor series for n terms. Now what is the difference? If f of x is the function and then Taylor series is given for this function as this, definitely there is some error. Let us say residual or error is Rn of x. Now when this n approaches infinity, limit n approaches infinity, this value approaches 0. That means in this equation, if I go till infinity, then I can exactly produce the same function. But till infinity means some values you will take, some large value of n, so that I can approximate f of x to this polynomial function. That is the meaning here. In real world, there will be many problems where we cannot exactly solve the given function. In that cases, usually approximate using Taylor series or Maclaurin series. Let us take some simple examples. So find the Maclaurin series, okay, for f of x equal to sin x. So for sin x function, you have to find the Maclaurin series. That is Taylor series with a equal to 0. So we already know it can be given as f of a plus f dash of a into x divided by 1 factorial plus f double dash of a into x square by 2 factorial and so on. Here I'm not taking x minus a. See, it is as good as writing x minus a whole square. Okay, x minus a into x minus a here. But as already given Maclaurin series means a is equal to 0. Just that's why I'm writing it directly like this. Now first you have to find f dash of a, f double dash of a, and so on. So how many terms you want? So many terms you have to find the differentiation. So first f dash of a is 0. So f dash, so let us find first f of a, f of 0, that is this first term. So this is equal to sine of 0. Sin 0 is 0. Then f dash of 0, cos x. To put 0 here, we'll get 1. Now f double dash of 0, differentiation of cos x is minus sin x. So again 0. F double triple dash of x means third derivative. You'll get minus cos x is equal to minus 1. F the fourth derivative of x equal to, so derivative of this is sin x equal to 0. So you can go on till how many terms you want to add. Now, so this I go on substituting now. F of 0 is 0. 0 plus f dash of a. F dash of a is 1. 1 into x divided by 1 factorial plus f double dash of a is 0 into x square by 2 factorial plus next f triple dash means is minus 1 into x cube by 3 factorial. Next plus 4, 0 into x to the power 4 by 4 factorial. So I can go on doing like this. So if I see this, I'm getting it as x by 1 factorial plus 0, then minus x cube by 3 factorial, then plus 0, then if I go fifth term, so it will be like this, x to the power 5 by 5 factorial minus will be plus, and this will be minus. You can check it. 7 factorial. You can go on till infinity. How will you generalize this? You can generalize this as a summation of, let us start n equal to 0. Let us say this is n is 0. This first term, second term, third term till infinity. So n equal to 0 to infinity. You check out the order here. See, sign is changing for every alternate value. So when n is even, it is, when n is 1, for example, it is negative. When n is 3, it is negative. So n is 2, positive. N equal to 0, positive. For means for even numbers, it is positive. So minus 1 to the power n. See, minus 1 power 0 is 1. Minus 1 power 2 is 1. So it will be positive value, these values. If it is odd number, minus 1 power 1 is minus 1. This is odd. So it will get minus sign into. How is x varying? When n is 0, the x value is 1. When n is 1, x value is 3. So that means what? This 2n plus 1. You go on putting n value, I'll get that this order. Similarly, denominator in terms of factorial. So it is nothing but x power 2n plus 1 divided by 2n plus 1 factorial. This is just to give in a summation form, but you will be directly using these functions when you apply in your problems. So that is for Taylor series or Maclaurin series for your sin x function. Now we'll see again Maclaurin series for f of x equal to e power 2x. That means what? My a is again equal to 0. So f of x equal to e power 2x. So how will I write my Taylor series? F of a plus f dash of a into x minus a. Okay, this is Taylor series. 1 factorial plus f double dash of a into x minus a whole square divided by 2 factorial. F triple dash of a into x minus a whole cube divided by 3 factorial. So on till infinity. Now, Let us find the derivatives. First find f of a. The a here equal to 0. A is 0. So f of a will be put e power 0, that is 1. Now f dash of a is equal to 2 into e power 2x. So let me write f of 0. So this will be equal to 2. F double dash of 1 is equal to, 0 is equal to 4 into e power 2x. That is 4. F triple dash third derivative at 0 equal to 8 e power 2x is equal to 8. So F fourth derivative will be equal to say 16 e power 2x, that will be equal to 16. So how many terms you want? Those many terms you can find. Now just substitute here. F of 0 is 1. 1 plus f dash of a is 2 into x by 1 plus f double dash of a is 4. 4 into x square by 2 factorial plus 8 into x cube by 3 factorial. So it goes on like 16 into x to the power 4 by 4 factorial till infinity. So I will write summation form. You will summation say n equal to 0 to infinity. Now you see the terms. Let's say this is n is 0, 1, 2. Okay. N is 0, 1, 2, 3, 4. So how are they varying? So if you see the denominator, put it as 0 factorial, so n factorial. So denominator is n factorial, right? There are no negative terms, so all are positive, so no need to write minus 1 power something like that. Now, how n is varying with this? Let us say it is 2 power 1 means 2 power 0, 2 means 2 power 1, 2 power 2, 2 power 3. So it is nothing but 2 power n, right? Into however x is varying, again x same, x to the power 0, x power 1, x power 2, x power 3. So into x power n. This is the Maclaurin series for e power 2x. Next. So given a logarithmic function, how will you find? Say f of x is equal to natural log 1 plus x at about x equal to 0. So that means a is equal to 0. So this is equal to f of a plus f dash of a into x by 1 factorial plus f double dash of a to x square by 2 factorial and so on. Now find out f of a, that is f of 0. So f of 0 is log of 1 plus 0 is 0. Then f dash of 1 is equal to 1 by 1 plus x. Differentiation of log 1 plus x is 1 by 1 plus x. So this will be equal to 1. f double dash of 1 equal to, so differentiate this, I will get minus 1 by 1 plus x the whole square, right? So f double dash of x, you will get it as minus 1. Then again go on differentiating this. So I'll get 2 divided by 1 plus x cube. So this will be 2. F fourth derivative is equal to minus 6 divided by 1 plus x to the power 4. So this is equal to minus 6. So now we substitute f of a is 0, 0 plus 1 into x divided by 1 factorial. Next minus 1 into x square divided by 2 factorial. Next plus 2 into x cube divided by 2 factorial plus minus 6 into x power 4 divided by, this is 3 factorial, this is 4 factorial. Now you simplify this. So let us ignore this 0. X minus x square by 2 plus 2 divided by 3 factorial. So 3 into 2, 2 to cancel. So x cube by 3 minus, how will you solve this? X to the power 4 by 4. Okay. 4 factorial if expand, it is 4 into 3 into 2. This is 4 into 6. So 6 is cancelled. Now it goes on like this. Now how will you generalize this? So this is summation of, say, this is n equal to 0 I have ignored. So let me take it from 1. 1, 2, 3, 4. So n equal to 1 to infinity. Now how they are varying? The sign, when it is odd, it is positive. When it is even, it is negative. That means minus 1 to the power n means it will take even numbers, even n value will be even. So that will be positive. So it is n minus 1. So when n is 1, minus 1 to the power 0 is 1. Then when n is 2, this case, so I should get minus value here, no? So 2 minus 1 is 1, minus 1 to the power 1, so minus 1 into. Okay, if you observe the denominator, how they are varying, denominator just is by n only, no? This is x by 1, x square by 2, 3, 4, n, the n value only. So n equal to 1, 2, 3, 4. Then x is also same, x power 1, x power 2, x power 3, x power 4. So it is also x power n. This is the Taylor series for your logarithmic function 1 plus ln 1 plus x. Now we'll see, so how will you solve your limits problem. In limits problem, when you have L'Hopital's rule to be applied, you have to repeatedly apply it. So if you convert that any given function, okay, in the Taylor series or Maclaurin series, then it is easy for you to approximate and then get the limits value. So that's why you can use the Taylor series here. Let us see a few examples. Let us see, this is limit 1 plus x minus x plus x square by 2 divided by x cubed. So it is in what? 0 by 0 form. If it is 0 by 0 form, I can apply L'Hopital's rule, but I have to repeatedly differentiate these. So for example, if it is x power 8 here, so 8 times you have to differentiate repeatedly. So instead of that, we can just approximate this function using Taylor series. Let us find this value for this, okay, using Taylor series. And also I should see that what is the highest order in the denominator. It is saying x cube. So it is sufficient if I expand this log of 1 plus x till the x cube term, x cube polynomial using Taylor series, then it is sufficient. So again we'll write that, already calculated this anyway. So f of x equal to log of 1 plus x. So let me write, it is f of a plus, so what is a value here? X is 0 here. Okay, please be careful about this. If they give you x approaches a, you have to put a value. For example, if x approaches 2, so some limit is given and function is given, and then it approaches 2 means what? A value will be 2. Okay, every time it is not 0. So be careful and read the question correctly. So then it is f dash of a into x by 1 factorial plus f double dash of a into x square divided by 2 factorial plus f triple dash of a into x cube by 3 factorial. Now this is sufficient for me because denominator is x cube. So what is that I get? So previously I got it, right? So this is what I get, x minus x square by 2 plus x cube by 3. So this is x minus x square by 2 plus x cube by 3. So limit x approaches 0, then minus this minus x plus square by 2 whole divided by x cube. So these terms get cancelled. So x cube by 3 divided by x cube is 1 by 3. So easily you can get the answer. Okay. Next. Similarly, it's given as sin x minus x by x power 7. Okay. So I have to differentiate it 7 times numerator and denominator if I apply L'Hopital's rule. It is in 0 by 0 form. So instead of that, what we can do? We can approximate this sin x till the polynomial has 7. So already you know sin x. Sin x can be given as what? It can be given as x minus cube divided by 3 factorial plus x power 5 divided by 5 factorial minus x power 7 divided by 7 factorial. So till this term is sufficient for me. Here minus x. Okay. So this is limit x approaches 0 divided by x power 7. Now, if you observe here, so you can, so this x gets cancelled. So this will be limit x approaches 0 minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x power 7 by 7 factorial. These signs are very important. X power 7. Now, you can approximate this. See, these are the small terms, x cube and then x to the power 5 compared to x power 7. Okay, so that means x power is the highest order. So it is having minus. You can write order of x power 7 divided by 7 factorial into x power 7. Okay, so this is limit x approaches 0. That is approximation in the limits chapter I explained you. So it is order of this x power 7. This is the dominant term. So I can directly write this because these are negligible compared to x power 7. So that means this is approximately equal to this. You can just say becomes 1. So minus 1 by 7 factorial is equal to minus 1 by 5040. This is how we can solve. If you apply repeatedly this, then it becomes a very big number. See, the logic remains same. See, if I go on differentiating this, what is that I will get? If once I differentiate 7 into x power 6. Okay, next I differentiate, I will get 6 into x power 5. See, this is what I am multiplying, no? 7 into 6 into 5 into 1. So this is nothing but 7 factorial. That's what I am getting here. Okay. Thank you for watching. We will solve few more problems in the next video. Please like, subscribe and share with your friends.